this talk will be probably about OCaml, as you noticed on the slides. You might think this is an introduction slide. No, this is already the content, because you can see there the name of the language. This is the first thing I wanted to tell you. The language is called OCaml, which is with a capital O, with a capital C and ML, because it used to be called different things and people are not clear on what it is. It used to be called Objective Camel. Some people also write it with a dash, like an Irish surname, but it's written like this, and now we're clear that the language is called OCaml. So, a little bit about me. I'm from the Technical University of Munich. I'm originally from Poland. And my first contact with OCaml programming was in university, actually. I did functional programming before, but in Scheme, and in university I got into a course. It's mandatory for all second-year students. And that year it was in OCaml, and I thought that was actually pretty nice. So I saw a poster. When it came to writing a thesis, I saw a poster on the doors. It says, wanted only alive OCaml programmers. From a guy who became a thesis advisor, and I did my bachelor thesis writing OCaml code, which I kind of enjoyed. And then came to master thesis, and now I deliberately looked for something and found another project at a company in Munich where we work with OCaml. And so I was pretty happy to present the language, because I really like it. First, why? Why should I even care? There's a number of reasons why OCaml might be interesting for you. There's a whole slide with things. So, OCaml is a statically typed ML family language. It has a Hindley-Milner type system with type inference. It's also extended in many ways, so every language goes to some other paths and has some other extensions. What's important about the ML family and OCaml itself is the module system. So it's basically you put your code into modules and then you can compose them. It works like this. This functionality is called functors. So you can put your code there, put signatures there, and say, well, this spot can be parameterized with a different code from a different module. What's also important about OCaml, which is for years, it's fast in average case. So it's not the fastest language, but it's not particularly slow either. The usual code is pretty fast, so you don't have to do crazy optimizations with making things strict or lazy to get optimal performance. It just works mostly decent. As you've seen, it's also strict, so there is optional laziness. You can add it, but the default is strict. I think it's easy to learn. We use it in university for teaching. We also use other languages. This year we use Haskell. And I think the OCaml way is just easier for students to pick up. It has native and bytecode compilers, so if you want to develop your code, you can just use the bytecode compiler. If you want to ship the code, you can just use the native compiler. The native compiler is pretty nice because it supports a variety of platforms. You can compile it on Windows, and Linux, and Mac OS X. You can use it on ARM, you can use it on MIPS, you can even use it on ARMv6 like the Raspberry Pi, which is pretty nice, which is something that I actually did. It's also one single language, so there's the OCaml language, and most code is written in this language. There's no, once you've learned the language, you mostly know it. It's not like, oh, I can add a compiler extension and then things just go crazy and semantics change. It has a macrosystem. This macrosystem works like this. So the compiler just dumps an AST, and you can add a post-processor that transforms this AST, and then the compiler reads it, and then you have your macros. There's some support for that in the language, for constructs that you can add for your macros. And it tends to have good backwards compatibility, so any code you wrote in 1999 or 1995 should be able to work more or less still in 2015. Maybe I thought about two target groups that you could be coming from Python or like any other dynamically typed language like Ruby or JavaScript. So what does OCaml bring to the table for you? This is just Python as an example. Something that's very important to me is stronger correctness assurances. So I work on a software and I don't know everything from the software. It's a compiler and I haven't written it all, I just use it. And when I change something, I want to know that I haven't missed something. And this type system allows me, it says, when I change something, it immediately says when I try to compile it, this doesn't work because you mismatched the types or you forgot the case. That's very, very useful for refactoring. What's also nice is the faster execution. You can compile it to native code, which is pretty nice. What I really, really love and what I really miss in many, many languages is the pattern matching. So you have data types and you match on the data types, and you can be sure that you got all cases and you can destructure it. Pretty nice. And the community is focused on functional programming. OCaml supports also imperative programming. It's not a pure language. But this paradigm is not too popular. You can, if you want to, you can cheat in your functions, use a for loop or a while loop, or you can use objective programming, but nobody does so very much. So the community is mostly focused on functional things, which is, for me, it's pretty good, so you don't have like a terrible mishmash of object-oriented functional code, which gets very complex very soon. From a Haskell perspective, there's not so much. The learning curve is, in my opinion, much gentler. You don't go into much theory. Once you learn it, you can mostly read the code that other people wrote. Also, this module system is pretty nice. You have the modules with the code, you have the signatures, and you can parameterize it. Some projects do that heavily. For example, they have there is an operating system written in OCaml, and it can be modularized because you can develop your code on Unix, and then you can just switch the module to the native module and then compile it down as a kernel. That's pretty neat. That's allowed with functors in ML. Another interesting thing is, in my opinion, is JS of OCaml. It just takes the OCaml bytecode and it can generate JavaScript code from that. The code that's generated is surprisingly fast. I've seen 3D renderers written in OCaml compiled to JavaScript. It ran on my computer from 2011 in 60 FPS in the browser, so that's rather neat. You can have the top level or the REPL in your browser running, so you don't even need to install OCaml. You can just download this JavaScript blob, execute it, and try OCaml at home. Also, there is AltErgo. This is an SMT solver written in OCaml, and they even made a online version where you can type in your clauses and get a solution out of it, all running in the browser, but also all OCaml code. There's another project which has been around for a couple of years. It's called Oxygen. It allows to run OCaml code on the free front and back end, and you just write everything in one file and you can share code easily. So it's like front to back development, which everybody says, oh, that's nice, you can use JavaScript on the server and on the front end, and now you can use OCaml on the server and on the front end too. People say, yeah, that's nice, but it's unpopular. Well, it's number 38 language on GitHub, which is not too popular, right? But there's a couple of startups like Issue, or I don't know, maybe you heard of Facebook, which uses them. There's Citrix, they do Zen things, they have this Zen virtualization and the tools are all written in OCaml. Jane Street, they do Wall Street trading. Shiro is a game company. They wrote a Haskell compiler, an OCaml compiler for their own language. Hatse it's called, and it's rather popular. Yeah, there's a little bit of stats. There's a repository for libraries, and this is the graph of contributors. The repository was established somewhere in 2012, and it's on GitHub, and everybody can contribute a library, and the growth has been pretty good so far, I think. from basically 0 from the people that just created it to now over 250, I think it's 260, somewhere around that. People who are contributing, and you see the growth is continuing. It's not flattening out yet. Still, the popularity argument, there's a number of software that you might or might not have heard that uses OCaml. There's zero install. Zero install used to be written in Python. Then the guy who wrote zero install had some issues with deployment of the Python software, and he decided to look into more languages, and he picked, I think, Haskell, OCaml, Go, and D, and I think even Rust, I'm not sure. And he did a big shootout, and then he decided for his requirements OCaml was the best. And since that, he started a really nice blog post series of a Pythoneer coming to OCaml and what his experiences with the migration were. There's also PFFT, and Flow and Tag, all of three of them from Facebook. PFFT is an analyzer for source code. Flow is a kind of type system for JavaScript, and Hack is this compiler for their own PHP-like language. There's Huxley, which I already mentioned, another compiler. The Rust compiler used to be written in OCaml, which you can see. OCaml is pretty popular for compilers, and many languages which were implemented in OCaml tend to pick some features from the language. For example, the option types in Rust are very similar to OCaml, and the language I'm working on is also very inspired by OCaml. There's Comstart, which is another compiler which is formally proven. Pharmacy is a C framework for analyzing software. There's FTV, which is a fast Fourier transformation library. So you see, there's a lot of scientific software. There's COP, which is a theorem prover. And there's Branchman, which is an interesting thing. It's a small project, but it's a tool to call Java closure code in a fast way. Because the JVM has a long startup time and OCaml doesn't, so the author of Leiningen wrote a tool which just calls it faster. You see, it's rather popular for compilers. I don't know, that's fun. Okay, so we saw that there's some nice examples of OCaml, so why is not everybody all over it? Because it's a nice language. And in my opinion, the biggest problem is getting into it, getting started, because the infrastructure used to be rather hostile, and this thing is changing now, and I want to give you some guidance if you want to start how to do so. So, in 2014, I think, there was this nice book published. It's called Real World OCaml, by three people: Yaro Minsky from Jane Street Capital, Anil, oh, sorry, his name. His Twitter handle is awesome, by the way. And from Cambridge, and Jason Hickey, who was writing a book earlier about OCaml. It's the best book on OCaml that was ever published. There used to be books before, but they were very dry. And this book is very in depth, but it's also very interesting. I read it on sunny days in the park, and it's for more experienced developers, so it doesn't waste your time telling you how to set up your computer. It doesn't tell you how to install an editor. It just goes right into the thing where you can start programming, and it also covers a really huge range of topics. It covers functional programming, it covers even object orientation, it covers how the runtime works. It also has some interesting choices. It uses a different standard library, because the standard library shipped with OCaml is rather lacking, so they use this library developed at Jane Street. That's an okay choice too. And the nice thing is it's freely available online, so you can just open your browser, go to realworldocaml.org.com, and just start reading it. Or you can just buy a paper copy, that's fine as well. And for more starting developers, there's also OCaml from the very beginning. which teaches you, well, if you have never touched a computer, you have never programmed, then this book is for you. It's a rather short book. It covers functions and how to call them. And it reminds me a little bit of the Little Schemer, because it's very brief and it's not too daunting, I'd say. There's also another book coming out soon, or even published now. It's called OCaml, which is a follow-up to that book. If you like that, then there's another one.
Does it also have a camel on the top, on the cover?
I think it does, but it's a different camel. Yeah, but learning in isolation is difficult, at least for me. If I have issues, I want to be able to talk to someone who can point me to the right direction. I don't want to lock myself up and then try to figure it out. I want to ask a question and get maybe some tips. There's a number of communities out there. There's my favorite community. It's #OCaml. It's #OCaml on Freenode, a channel where you can usually get very, very good quality answers. That's the advantage of smaller communities, where you can get good answers even for not so smart questions. There's also the OCaml beginners mailing list, which is geared towards more beginners. Then there's Caml list, which is for more advanced programmers, and you can get all kinds of even tricky academic questions answered there. There's also this OCaml tag on Stack Overflow. So there's people answering questions there as well. So, now I assume we've learned OCaml now, so how to edit it. There's a number of editors that are popular. There's not much IDEs that are too popular in OCaml world, because the language is not full of boilerplate, so you're pretty much okay with an editor only. For Emacs, there's 2 modes that you can use. For Vim, there's a syntax mode, which is bundled with the editor, and there's also some niceties to replace operators, and lambdas turn into actual Unicode lambdas, so it's just a little bit of toys. There's an OCaml plugin for Eclipse, but I haven't tried it because I'm not a big Eclipse fan, but maybe it looks good. And one very, very important tool, in my opinion, that just surfaced in the last couple of months or years is Merlin. Merlin is a third-party helper that understands OCaml code. So you write your code, and it parses the code, and it offers you a lot of features on when working with the code in your editor. So it offers completion, so you can just say, oh, I'm not sure how this was called, just press tab, and then just shows a drop-down box. It does type inference, so if you deep into some code base, and you want to know, oh, this expression, what is the type of it? Then you can just press some buttons and it just displays you the type of the thing, which has been, well, a game changer for me, because I started to work in a huge code base and I knew nothing of it, so I can just infer the type of some expressions, and I'm smarter. It also allows renaming, and you can jump to the definition of the things. And it's a third-party tool, and it's available with, in Vim and Emacs, and also Sublime Text. You can just use it from any editor, which is pretty nice. So, for example, if you want to know, there's a module called list, and it contains operations on actual lists. And if you don't know what it does, you can just ask the editor. Well, there was something with map, maybe. So you can just press, type in list.m, and then tab, and you see there's a number of operations on the list module, and you see there also the signatures of these functions. So that's very useful for me. Okay, so building code. You wrote your code, you want to build it. Usually building code sucks. Building code sucks because you have to get the inter-project dependencies, which files need to get compiled, which one depends on which other file. Then you have different projects where you have dependencies on some external projects. and you need to track that, and you need to build them before your project, and you need to build your files in a certain order. If you change something, you don't want to rebuild everything. Maybe you want to just rebuild parts of it. Build times can suck too if it's too much, and you need to care about compiler options. And in Haskell, this is all handled by Cabal, which is a nice system, mostly. But in OCaml, it used to be quite terrible, so you have these .ml files for your source code, .mli for the interfaces, which is basically the signatures of your modules. Then you have .o files for the compiled C code. You can compile and link C code together with your OCaml code, which is really useful for interfacing with external libraries. Then there's compiled modules, then there's compiled native modules, then there's compiled archives, then there's type information annotations dumped by the compiler. And it used to be terrible, and there's also this OCaml C compiler, which is the bytecode compiler. Then there's the OCaml C.opt compiler, which is the native compiled version of the bytecode compiler. Yeah, and there's the OCaml opt compiler, which is the native optimizing compiler, and this OCaml opt.opt compiler, which is the natively compiled native compiler. And there's OCaml deb, which calculates dependencies. And it's all terrible, and I heard some laughs already. So yeah, there's this used to suck. So there's some solutions for that now. There's libraries written down and tools written in the last couple of years. For example, the most important library is OCaml find, which finds packages. This means in OCaml, the OCaml compiler does not have a concept of packages. So you have just module files. You have just compiled module files, and if you want to use them, you need to specify them to the compiler. This is rather annoying. So there's a tool written for it. It's called OCaml find, and you write it in front of the compiler call. And it has an additional option which is called package, where you can specify the package that you want to use. For example, you want to use async, then you just add -package async, and it just includes all the compiled module files for this call. And this information is specified by the library author. This is from a file called meta. And the tool is very established in the community. Everybody writes his libraries now with the meta files, and you can just install them and use them. There's another thing. OCaml didn't used to ship with a building system before. So, well, if people learn a language, the first thing they do is like, oh, I know, I write a build system. And then, well, 1, 2, 3, 4, 5, 6, 7, 8 build systems later, everybody decided, well, this was a terrible idea. So OCaml 3.12 shipped with OCaml build, which is a pretty nice build tool. You can just specify what you want to build, and it has some default rules to invoke the compiler with the tools, with the packages that you need. You can also specify a underscore text file where you specify which packages you need and adjust the compiler options if you want to. It's rather nice for small to medium projects. For smaller scripts, just one file, it just does not need any configuration. You can just call it and it just builds a binary and it works. It's rather popular, but it's not as accepted as OCaml find. Then we continue, we have built it, but it's rather annoying, right? You first need to have this configure script, which checks if you have all libraries that you want to have even installed. Then you have this meta file where you specify which modules your package has and which are the dependencies between them. And you have the text file where you write the configuration for the build system. And it's rather repetitive, so if we just had a tool that does this, and enter Oasis. Oasis is a tool which is heavily inspired by Cabal. It is another file, it's underscore Oasis, where you can just specify the options, the license, the name of the package, which libraries to build, which modules are there in this library. And it can just generate all information for you. It can just generate the meta file, you can just generate the text file. And in theory, it would also support other build systems. If you want to use your own build system, you can write a plugin and you can plug it in. There's not much build system plugins yet, but if you want to, you can have it. This system is not too popular. I like it, but other people don't. So you see there's a lot of fragmentation. This is how this Oasis file looks like. So it's just the version of the format, the package name, some license, the build tool that is supposed to be generated, the dependencies, the packages which you want. In this case, it's a HTTP library and a JSON library. And then you can generate all the build tool and all the craft for your project from out of this. So you have now successfully wrote your program. You have built it. That's nice. And now you need to figure out if it even runs correctly. So there's different kinds of testing you can do with your program. Of course, this list is not comprehensive. There's just too many to mention. But there's like assertion-based testing, like this classical JUnit, XUnit tools, where you just specify some information and you check whether the result from a call is the same as you expected. There's property-based testing, where you specify the property of your code and then the language or the library generates data and checks whether whether your program processed the data in preserving this property. We'll see an example in a moment. There's enumeration-based things. If you know Haskell, you probably heard of small check. And there's also continuous integration, where you just build it on some other machine, and every commit will be built. Maybe with different compiler versions, maybe with different configurations. You can configure it how you want. There's this tool Travis CI, which you can integrate with GitHub. So every time you push a commit to your project, it builds it on a range of systems, and then it says and runs a test and tells you this worked or this didn't work. So the simplest way is unit testing. There's a number of unit testing libraries. The most popular is OUnit, not too creatively named. You see there, first you open the module, which means you insert all the names from this module into your namespace. You don't have to, but it's nice for slides. Then you define a test and check whether, well, 1 plus 2 is 2 plus 1. And then you define a test suite and run it. That's rather a bit of overhead. There's a syntax extension that you can use to shorten it. But overall, I wouldn't say it's too bad. It's okay. It's bearable. And if you're more into property-based testing, there's also a number of libraries. There's one, my favorite library for this is QCheck, which defines a number of names. For example, mktest, it takes a name. You can see there in the code a rather interesting property of OCaml. You can label arguments. Arguments can have labels. This one is called name. You can also have optional arguments, and the order of optional and named arguments doesn't matter. If it's optional, it just gets inferred as an option type, and if you don't specify anything, it's just filled with none. Then you say, okay, this function that I want to test takes a pair of small ints, and then the function that you're testing, and well, I'm testing that a plus b is b plus a, and here's the code to run it. I have defined this name, this function, and then I just run it, and if I run it, it says, yeah, indeed, after hundreds of runs, he determined that a plus b is actually b plus a. So the compiler is not broken. Nice. So another thing, continuous integration. You commit some code, and somebody else checks it out and says, well, it didn't work. So you usually say, yeah, it works on my machine. That's nice. But maybe you can do better, and the typical way to solve this issue is to use some continuous integration system. So I can build it on basically any system, but there's some interesting tools that are already provided for Travis CI. It works like this: you have your code on GitHub, and you add a .travis YAML file with the URL to the script. Here, you cheat around. You say it's language C, but it really isn't, and it just gets the script from this repository and runs your code with a number of OCaml versions. So you can know if you have changed something that breaks in a future or past version, you immediately spot it. You can define also different compiler options here, or different packages, or you can even take the same version and say, well, this dependency is optional, but let's see if it still works if I don't install this option or if I install this option. Pretty convenient, and you don't want to do it on your computer because it takes a lot of time. So you tested the code, and it hopefully works. Now let's go to distribute it to get it around. And as we've seen, there's not much agreement on build systems. So if there's a tool like Oasis, which is like Cabal, then we would like to have a repository of libraries which we can use. So the Haskell way to do that is called Hackage. And there was an idea of having the same thing, basically the same thing, called Oasis DB, but it didn't work out because not everybody wanted to jump on the Oasis train. So we needed to do something different. So there's a new package manager called OCaml, which stands for OCaml Package Manager, and it doesn't force people into using some specific build system. It's very simple. It's also nice because it manages building compilers and packages. So it's basically RVM or NVM and a package manager combined into one thing. So you can install on your machine 3 different compilers or whatever number of compilers you want with whatever special options you want. And the packages and OCaml will take care of switching between these versions. The package repository is community maintained, so there's no single person who uploads something and then he just stops and never updates it, but it's maintained, and you can add pull requests if you want to push a library from your library maybe, or someone else's library that you want to have this on the system. You can also create a pull request. It describes the packages. It says, well, it has this version number. This is the place where to get Tarball. It also supports Git and Mercurial, I think. Checkout. And this is the hash, so you don't get the wrong package. It also cares about dependencies and conflicts, so you can say, well, this package works on every system except for this old OCaml version, or it conflicts with this other package which it's trying to replace. Yeah. And if you want to install something, you type in OCaml install whatever, and then a SAT solver runs and tries to get the best configuration for you. And it also handles updates and removals. So if you want to update your installation, you don't have to delete your sandbox and start anew, but you can also just type in update, and then it just downloads all packages and updates only the ones that are necessary to update. It also handles removals, so if you remove something, stuff gets rebuilt that is necessary. And it works rather well. So here you see the number of packages that OCaml acquired in the last 3 years. The red graph is the total number of packages. They usually don't delete old versions, so if your code depends on an older version, you can still get it, no problem. And the blue line is the number of packages overall, so it's every single package is just there. And you see there's also some growth, so from, well, maybe 150 libraries to now 850 libraries in 2 years. That's pretty good. So, you've distributed the code, oh, then you should have written some documentation. There's tools for that too. It comes shipped with the standard library from of OCaml. It's called OCaml, which is in the tradition of Java. So you have this special, this is a comment, and if it starts with 2 stars, it gets picked up by OCaml and processed. It has a special kind of markup language where you can say, well, this parameter is called arg1 and it is used in this way or that way. And it's usually this documentation is specified in the interface files. And this tool is rather old, and the documentation that it generates looks kind of oldish, but there's a new attempt with OCaml, which integrates with the package manager to generate documentation for all packages. But it's not here, it's coming. Another interesting thing is if you're looking for a function. When I'm looking for a function closure, I post to the closure IC channel, I need a function that does this, and then somebody tells me the name of the function. It's not approach that scales too well. So there's in OCaml there's a better way. It's called OCaml scope, where you can search for your APIs in a number of libraries. It's kind of like Google or Hayu, if you know Haskell. You can type in the signature that you're looking for, and then it finds libraries that contain a function that has this signature. And it's not limited to the standard library. It installs about the top 100 OCaml packages it has installed and indexed there, so you can get your results instantly. You can also download it and install it on your own computer if you want to. Okay. So we saw what's there, but all this stuff changed recently. In the last 2 years, there were huge changes, and OCaml in 2010 used to be really terrible. OCaml in 2015 is much better, but it doesn't stop here, and we still have a lot of catching up to do. So what is coming? What's still coming is multi-threaded OCaml. Currently, OCaml has a kind of a global interpreter lock, so you can just run one OCaml thread at a time. It is in the works from people in Cambridge who want to extend it. It's currently, there's problems with the concurrent garbage collector, but I guess it will get ironed out in the future. But you can still use libraries that parallelize your computation in different processes, and then it works. But okay, if you don't want to have threads, you can also use async evented I/O. That's what all cool kids say. That's fast and great and whatever. And there's libraries for that. There's LVT, which stands for lightweight threads, and async from James Street, which all try to solve the same problem. And here's an example of this library. I think it's rather nice. I used to write Node.js code, and it's callbacks everywhere, and the code looks super cluttered. And coming from there, LVT is pretty nice, because you see here, that's a normal function. It's called channels history. It takes 3 arguments. One of them is optional. Okay, cool. Then it calls ID of channel. This function has side effects, so to say. It calls a web service. So I want to call a web service, and I want to get the result. And we use this lab keyword with the person sign and LVT. This is a syntax extension, which is basically a bind operator. So this can suspend, and in the meantime some other code can run. And when the result is there, it just jumps in into the function and into this body, and the channel ID is set with the value that I got from the service, and then I can start my execution, which I thread through. I start with this endpoint function. It gets me a URL, and then I add some headers and some authentication information, and then I just return a JSON response. So there's no callbacks, no error things. If there's an error, you get an error type out of it. So another thing is, which I really envy the .NET people, is F#. They have this basically OCaml on .NET. Statically typed ML, and it's a really serious effort because Microsoft really puts some thought into it, puts money into it, puts people onto it. It has integration with Visual Studio, so they're taking it really seriously. And the JVM users have, well, Yeti, which is kind of ML for JVM, but it's just one guy with a really ugly homepage for this. Sorry, I mean, it's great that he wrote it, but it's not used very much. And Scala, which is, well, it's not an ML, and I think it's rather, well, difficult to use, and not to my tastes, but maybe it floats your boat. So there is OCaml Java coming up. There's a beta out. It generates JVM bytecode directly. So it's basically an alternative compiler. It's based on OCaml 4.01, which is the version before, but it'll catch up eventually. The performance is faster than the OCaml bytecode, but it's slower than native code. But it's still an early effort, and I suppose it will change. And it can also use the JVM runtime, and it can also use threads, and it can also use everything that the JVM offers. That's pretty nice. But okay, that's the things that are coming. There's also other things coming, but I can't possibly see all of them. There's things that are missing still, sorry. For example, the debugger. There's OCaml debug. It works, you compile your code to bytecode, and it gets some instrumentation code, and you can start it. And the debugger is pretty nice because you can say, okay, just do a breakpoint in 1 minute of execution. Or you can just say, do a breakpoint at some function or program. But you can also travel back in time, so rewind all that execution that you had. That's pretty nice, but the problem is that it's not too pleasant to use because it tends to step often into the standard library. The standard library is written in OCaml, so it shows up in the traces, and you're like in the implementation of list.map, and you're like, yeah, pretty sure debug is not in list.map, but somewhere else. And it has some issues with displaying the abstract values because it can't introspect the code, unfortunately now, and it has some bugs, so you can crash it rather easily. So I hope there's gonna be some better debugger sometime soon. You can do print debugging, of course, but this is not maybe the best approach. What also is missing is profiling. We have some huge code, and we want to know where most of the performance goes. And there's OCaml prof and gprof. Gprof is a general purpose profiler that you get from Linux. They work on bytecode and on native code respectively, but unfortunately the granularity is too low. So OCaml prof can display you how often a function was called, but sometimes it's not interesting, or if it's called very often but spends a little time, then it's not interesting. And gprof is just too broad. It just displays you all the number of calls and all the time that was spent there, but you don't see too well where your time spent. The call count is just useless, and also they are very buggy, so the times are not too accurate, unfortunately. But still, these are minor things, and I think the language is really interesting and it's shaping up, and you get the chance to change a lot of things. You get the possibility to get into the community, create some great libraries. There are some great libraries coming up and already there, so this is a great place to be in right now. So I encourage you to just pick it up and get the book and maybe write some libraries. And if you have questions, I'm happy to take any questions now.
Yeah, let's speak here. Thank you very much for the talk. I really enjoyed it. I wanted to ask you, it sounds like you've been using OCaml for quite a while, and I wanted to ask you, first of all, if you had more of an imperative background before, like in something like Java, and if so, how long do you think that it took you to get to a point in OCaml where you were able to be about as productive as in some other imperative languages?
Yes, I did have background in basically Python or whatever else object-oriented language you might want to use. I don't think it's that difficult. You have to get into the functional thinking, but you're not immediately forced to, because you can still fall back on imperative programming. If you're like, I have no idea how to express this problem as a fold, then just don't. Then just write a for loop and it's fine. You can have mutable variables. They're not mutable by default, but you can have them. And it's fine, nobody will kill you for that. There's no anti-imperative programming mob in OCaml. So picking it up, well, I can't say a really time frame because I had some prior experience with other functional programming languages.
Okay, other questions? I have one probably stupid question, but if OCaml did not exist, what would you do? Would you use other language? Or I don't think. Which one would you prefer?
I think if it wouldn't exist, the most comparable language is something like Haskell, of course, and probably use that.
Isn't it closer to Scala, actually?
Sorry?
Isn't it closer to Scala?
No, not really. Because
from your presentation, I wasn't really able to spot any serious difference between OCaml and Scala, while Scala being much more mature. All these issues you spotted, that we have to develop better building system, debugger, profiler, and so on, is already there for Scala.
Yeah, the difference is the syntax is completely different, and it's a much, in my opinion, it's a much simpler language because it's more limited to it doesn't try to scale up and it doesn't try to cover all grounds. It covers the functional programming grounds pretty good. It covers the object-oriented ground, well, kind of, but it doesn't try to be the one be all and all of languages. So it's overall a simpler affair.
I think you have to rule out everything about object-oriented from OCaml. It was a mistake, and they should not have gone down that route, and everybody that does anything serious with OCaml will not touch the object-oriented parts.
Yeah, that's true. Yeah. So basically,
so it's a disease, and it should not be.
Yeah, the predecessor of OCaml wasn't object-oriented. It was Caml Lite or Caml Special Lite, and it doesn't have. That's where the O comes from. It used to stand for objective, but they dropped the objective part.
You mentioned that companies like Facebook used it for static analyzers and compilers. Are there any language features why they use?
Yes, I'd say the algebraic data types and the standard library is quite useful for writing compilers and tools like that. And there's the compiler, the OCaml compiler itself is written in OCaml, so you can just be inspired by its source code. Also, it ships with a lexer and a parser, so you got the most useful tools for writing compilers and analysis tools already in your standard library.
Okay, let's thank our speaker again.